Dear students, in this session, we'll learn about electron displacement effect, that too inductive effect. In earlier session, we were discussing about inductive effect, how the inductive effect takes place, what is positive inductive effect, what is negative inductive effect. In this session, we'll discuss about the important features of inductive effect and as well as applications of inductive effect. What is the use of inductive effect, how the acidity and basicity will be depending on inductive effect. First, we need to know that the important features of inductive effect. It is a permanent effect. It is a permanent effect. And there will be the complete transfer of electron. We notice that no, there will be transfer of electron and shading of electron. Here, the shading of electron, due to shading of electron, covalent bond will form. In that, between carbon and other group or attached group of an atom or to the molecule, the sigma transfer of electron of sigma will be takes place. Means through this operation, sigma bond, sigma electrons are displaced. Sigma electrons are displaced. And it's generally observed in the saturated compounds. Saturated compounds, a carbon, single bonded compounds. And this shared pair of electron, so shift permanently, shifting of sigma electron or shared pair of electron permanently towards more electronegative group. Due to that, it will be forms and polarity. So polarity will be forms, and due to that, the substituent group, attached group will be getting partial negative charge and carbon will be having or acquired and partial positive charge. On the carbon, partial positive charge. And what happens in the inductive effect? So this, we know that the polarization will be begins, polarization. But in the case of the more than two carbons, if the group attaches to, means CH3, CH2, ethyl group. For the ethyl group, the chloride, bromide or halides are attached. Then what happens here? The dragging of electron from the first to a second, first carbon to a second carbon decreases. So we'll be representing, we'll know that so chloride Cl will have the partial negative charge because shared pair of electron towards more chloride. So compared to this second carbon, so carbon, first carbon will be having partial positive charge. Compared to this will be dragging tendency will be decreases from first carbon to second carbon. Okay, if the more of the substituent group attached to carbon, then the stability of that group will be enhances or increases. Stability increases. So this inductive effect brings changes in physical properties. Physical properties like dipole moment, solubility, etc. Dipole moment, solubility, okay, and like an other chemical reactions also, other chemical properties like acidity, basicity. So these are, they can vary with the inductive effect or attached group or a group of atoms. Okay, this will be carbon hydrogen bond is taken as the standard of inductive effect. Carbon hydrogen bond is taken as standard to represent the inductive effect. Below this bond or the greater than hydrogen electronegative or less than hydrogen electronegative. So based on that, we acted the negative inductive effect or positive inductive effect. Okay, so withdrawing capacity of hydrogen based on we kept the withdrawing capacity of hydrogen greater than or less than that, we can able to identify the inductive effect, positive inductive effect as well as negative inductive effect. So what I explained this, we can notice, we can see the points now. Okay, so So permanent shifting of, so it is a permanent shift of molecule or ion operation through sigma bonds. Only sigma electrons are displaced here and generally observed in saturated compound, carbon-carbon single bond, carbon-carbon double and triple bond because as an unsaturated compounds. And the shade pair of electron, although permanently shifted towards more electronegative atom, it remains the same valence shell. Okay, so understand, did you get this? Shade pair of electron, although permanently shifted towards more electronegative atom, it remains the same valence shell, the same valence shell itself, but the shifting of electron towards any more electronegative group. As a result of electron shift, more electronegative acquires and partial negative charge, a substituent group, partial negative charge, and the other group means remaining group will be getting partial positive charge. Next, inductive effect is not confined to the polarization of one bond, but it is transmitted along the chain of carbon to sigma bonds, atom through the sigma bonds. However, this effect is insignificant beyond the second carbon chain. That's what I said. In the first carbon, it is an affected. Okay, in second carbon, in the case of second carbon, this will be insignificant. So here it is an effect. It can drag the pair of electrons from first carbon, but the second, third, fourth carbon is insignificant. Okay, so along with that, these are the important features. Along with that, inductive effect brings changes in physical properties like dipole moment, solubility, chemical properties like acidity, basicity. Okay, these are the nature we can able to explain with the help of inductive effect. It affects the rate of reaction. Rate of reaction, how faster the rate, okay, how faster the reaction will be completed, we call as rate with respect to time. Okay, so rate of reaction can able to explain it. Affect means inductive effect, negative inductive effect or positive inductive effect, which can able to affect the rate of the reaction. Carbon hydrogen bond is taken as standard in inductive effect. So CH bond is standard. So zero effect is assumed to be this bond. For carbon and hydrogen, we assume that is zero effect. So apart from carbon, hydrogen, so any other group will be having, if atoms are a group which have greater electron withdrawing capacity than hydrogen, then it is having the minus I effect. I said electron withdrawing capacity greater than hydrogen. So drag the pair of electron towards themselves, then it shows negative inductive effect. In an atoms or group of atoms which have greater electron releasing power is nothing but less dragging power, then it can shows positive inductive effect. I said electron donating group. Electron donating group donates a pair of electron on the carbon from the substituent group. Then obviously carbon will be having partial negative charge and it is positive inductive effect. So you can write in the form of a definition. So inductive effect, it is also can be defined. Okay, inductive effect also can be defined. The substituent having the electron attaching group. So attracting power, if group of electrons or carbon attached to any other group, if the substituent having electron attracting power more than hydrogen are called electron withdrawing group. So nitro group of NO2, cyano group of CN, then carboxylic group of COOH, ester group of COOR. These are the electron attracting power. So more electron attracting power than hydrogen. If the more electron attracting power than hydrogen, what happens? Obviously, which can drag the pair of electron towards themselves from carbon to other group, then carbon will be having partial positive charge and substituent group will be having negative charge. This is called minus inductive effect or negative inductive effect. Okay, so similarly, another group, it's a substituent group having the electron attracting power less than hydrogen, electron releasing power, more electron releasing power, or it will be having attracting power less than hydrogen. These are called electron donating group. All alkyl group such as methyl or ethyl, CH3 or C2H5, isopropyl or isobutyl or etc. These are having less tendency to attract. These will have more tendency to release the electron. More tendency to release electron. This will be showing the positive inductive effect. Okay, so negative inductive effect minus I effect, positive inductive effect plus I effect. Okay, in negative inductive effect, so we'll be having attracting power. Substituent group will be consisting the attracting power. No, so negative group. So in the case of negative group, will be more attracting electron withdrawing capacity, negative inductive effect. Positive inductive effect, electron donating group. Electron donating group is all the methyl group. All the methyl group. So from this, what we can come to know that how we can clearize. So example, we'll take an example of carbon. Okay, carbon with a hydrogen, hydrogen and hydrogen. This is CH3 group. If to this methyl group, if chlorine will be attached to this methyl. So what happened? Chlorine is more electronegative, attract the shared pair of electron towards chlorine. So chlorine will be having partial negative charge and carbon will be having partial positive charge. If the partial positive charge is on the carbon, partial positive charge, delta plus on the carbon atom, so electron density decreases. So attacking reagent like nucleophile OH minus is nucleophile. This nucleophile, where it needs to attack, the less electron density. So less electron density on carbon, so it will form CH3OH with the formation of Cl minus. This is how the inductive effect plays in presence of an attacking reagent. So it is clear that the more substituted the alkyl group, stronger is the inductive effect. So from this we notice, no, compared to this CH3. Okay, and the order they said, this is an example. No? This is an example. Like another group of tertiary carbon like CH3 tries and C carbon. So there is an issue, it's 3 degree is greater than 2 degree, greater than 1 degree is nothing but CH3 twice and CH and greater than CH3 CH2. Okay, CH2. Next is greater than CH3. From this CH3 and this is CH3 thrice C. So what it can indicate? So more the substituted on alkyl group, stronger is the positive inductive effect. Stronger will be its positive inductive effect. So you need to know the difference between negative inductive effect and positive inductive effect. Negative inductive effect, more electron withdrawing capacity, drag the pair of electron towards themselves. So minus I effect, electron donating group, that is positive inductive effect. Okay, so based on the substituent group, if the substituent attached to the end of the carbon chain is electron withdrawing group, then positive inductive effect, this is electron withdrawing group. Okay, electron withdrawing group. So if it is donates, what happens? If the more electron withdrawing group creates a negative inductive effect. Electron withdrawing, so it is changes, no? Electron donating group, yes, it forms, yeah, it will be reversed. Electron withdrawing group is minus I effect. Electron withdrawing group is negative inductive effect. Okay, electron withdrawing group is negative inductive effect because carbon will be having partial positive charge and substituent group will be having partial negative charge. This is negative inductive effect, and electron donating group will be a positive inductive effect. So methyl group, so make it change, and this negative inductive effect and positive inductive effect. So based on the substituent group, if more electronegative group is the drag the pair of electrons and forms a negative inductive effect, an electron donating group, so it shows a positive inductive effect. So how this negative inductive effect and positive inductive effects affects on how these the dipole moment, how it will be varies, how the acidity basicity will be varies. Let's see the applications of the inductive effect. Okay, so applications of inductive effect in the first one, the stability of carbocation. We said that the carbocations, so that is in the order 3 degree is greater than 2 degree, 3 degree is greater than 2 degree is the primary. So is nothing but greater means more of the substituent group, the stability of carbocation will be more. So in the stability of alkyl carbocation increases with increase in positive inductive effect. With increase in positive inductive effect is nothing but the more of the substituent group, electron donating group. If the more group attached to the attached substituent group will be the electron donating, then greater is the positive inductive effect. In the case of plus I effect, okay, plus I effect in decreases with increase in negative inductive effect. If minus I effect increases, what happens? So carbocation stability is decreases. Carbocation stability decreases. As the number of alkyl group increases, alkyl group, no, CH3, more, then positive inductive effect increases. The stability is also increases. Stability also increases. So 3 degree is greater than 2 degree is greater than primary. So that is stability of carbocation. Understand? So positive inductive effect as the number of alkyl group increases. As the number of alkyl group increases, 3 alkyl group and 2 alkyl group and alkyl group. Here the more number of alkyl group, so this will be having the more stable than the primary. So tertiary will be more stable. Tertiary carbocation is more stable than primary carbocation. Remember, okay? Similarly, carbon anion, reverse to that is stability of carbene ion. Okay, in the primary is most stable than a tertiary. Primary is most stable. 1 degree is most stable than the 3 degree. Why this will happen? So due to the positive charge, so in the tertiary carbon, positive charge, there will be electron density decreases, attacking reagent can attack more easily because they will be experiencing itself the bulkier group, more of the bulkier group. So here electron density is less positive charge. In this case, electron density crowd, more number of electrons. Here the more number of electron and the methyl group, the steric hindrance is more, stability decreases. This stability of carbene ion increases with increase in negative inductive effect. If minus I effect increases, negative inductive effect increases with increase in minus effect and decreases with positive inductive effect. Minus I effect increases in positive inductive effect, it will be decreased. Stability of the carbene ion is decreases. So you need to remember, so minus I effect, negative inductive effect, drag the pair of electron. If they drag the pair of electron will be moved away from this, then it will be stable. If electron pair, if donating no, then again the stability decreases on the carbene ion. So positive inductive effect plus I effect, stability of carbene ion decreases, and negative inductive effect on negative inductive effect, carbon cation, carbon anion stability increases. Okay, are you getting this? So you need to remember the order. You need to know the order why this will be. Okay, more substituent group will be more stable in carbocation. So that is 3 degree greater than 2 degree greater than primary. In stability of carbene ion, that is 1 degree is greater than 2 degree is greater than 3 degree. There will be difference between carbocation and carbene ion. This both can be explained on the basis of substituent group as nothing but inductive effect. So for this, an inductive effect X group attaches to this, and if X group attaches to this, if X group attaches to this, then drag the pair of electron towards itself. So pair of electron will be here. So out of this CH3 and the CH3 thrice and CH3X, what will happen? Shared pair of electrons shift towards here more, negative inductive effect. The stability increases here. In the case of positive, if electron donating group increases, more electron density, it is unstable. But in the case of X, if more electron donating group on this electron donating group, which will be stable. Electron withdrawing group, already electron density is less. If furthermore electron removed from this, again stability decreases. So I think you need to understand properly between the inductive effect, minus I effect and plus I effect between stability of carbocation and carbon anion. Okay, so order you have to remember the order of the carbene ion and carbocation. Next, the strength of carboxylic acid. So this with the relative strength of carboxylic acid. Just a minute. So now the relative strength of carboxylic acid. We know that an acid is one, the species one which has tendency to lose a proton. Tendency to lose a proton is nothing but ease of separation of H plus. If we consider a carboxylic acid RCOOH group, in RCOOH group dissociates to form RCOO minus and H plus, right? So H plus proton is nothing but acid. Okay, so it depends on stability of carboxylate ion. RCOO minus is called carboxylate ion. This stability depends on acid strength, depends on this carboxylate ion. You need to know that RCOO minus carboxylate ion. This stability of carboxylate ion decreases when electron releasing group. Example, a methyl group. Methyl group on carboxylate ion. So RCOOCH3. Okay, RCOOCH3 is methyl group, electron donating group. So it is not withdrawing, it's not separating the group. Okay, electron will be donating to that RCOOCH3, means this electron pair shift on the carboxylate ion, then the decreases, acid strength will be decreases. Instead of this, what happens? Why this will be happen? Because electron donating group, the acidity obviously decreases. Instead of this, electron releasing, electron accepting group. If they drag the pair of electron away from this, then the more active, means hydrogen will be separating from the an oxygen group, electron releasing group. Okay, the group increases. In the case of alkyl group, the CH3 group. So what happened? So negative charge on the oxygen atom instead of the S pairing into the molecule. So example, HCOOH, HCOOH formic acid, or CH3COOH, an acetic acid. Okay, so what will happen to this? In this inductive effect increases. So acid strength decreases. Inductive effect between CH3COOH and HCOOH and CH3COOH. So here, so HCOOH is greater than CH3COOH. Compared to that bulkier group, example C2H5COOH group. Okay, so here 1H, here CH3COOH, like C2H5COOH, more of the carbon, more of the positive inductive effect. Plus inductive effect increases. If the plus inductive effect increases, electron donating group are more, acid strength will be less. Acid strength will be decreases. So acidity in the case of plus I effect, you need to understand plus inductive effect and minus I effect, negative inductive effect. In the case of positive inductive effect, electron will be donating on the oxygen. So then the acidity will be decreases. Acidity decreases. In negative inductive effect, if the groups are electron withdrawing, so what happened? The negative charge on this carboxylate ion, COO or COO or CH3. Example, I'll take which one? COO, which is a carboxylic acid. Okay. If this carboxylic acid, so what happened if electron withdrawing group are attached to this? Example, CH3COOH. CH3COOH is acetic acid. Compared to this acetic acid, CH3 is an electron donating group. Instead of this, if CH3 is replaced by one of the hydrogen, so keep on replacing by chlorine, it becomes CH2 ClCOOH, right? This is called as monochloroacetic acid. CH2 ClCOOH, monochloroacetic acid, one of the hydrogen replaced by chlorine. Then what happened? Electron density means what happened? Charge, negative charge on carboxylate ion decreases. So if the negative charge on carboxylate ion decreases, that acidic strength will be increases. Acid, more is the acid strength, more will be the acid strength. So understand properly the relative strength of carboxylic acid. In positive inductive effect, electron donating group are present, then acid strength decreases with increase in positive inductive effect. In negative inductive effect, the carboxylate ion oxygen charge on the oxygen. Okay, so here the charge on oxygen is more, electron density and more, so less reactive. Here what happened? Charge on oxygen is nothing but carboxylate ion, COO minus. In this carboxylate ion, so electron density, if we remove, no, it will be more active. So acid strength will be more. So negative inductive effect, in minus I effect, the acid strength is more. In positive inductive effect means electron donating group, like all alkyl group. So acid strength will be decreases. In carboxylic acid group, in COOH group, if it will be consist and methyl group, or if it is consist with an electronegative, example CH3, one of the hydrogen is replaced by chlorine, monochloroacetic acid, C3COOH acetic acid. Here complete electron donating group. So here electron withdrawing group. So charge on carboxylate ion will be decreases more acid strength, acidic strength is more. In the case of here carbon electron withdrawing group on carbon, so charge on carboxylate ion COO minus is more, this is less acidic. Okay, so you need to remember the acidic strength in the few of the compounds like acetic formic acid to an increase in carbon number and replacement of methyl group with a chlorine. Okay, so you need to remember this. RCOH dissociates to form COO minus and H plus. Inductive effect increases, so acid strength decreases. Formic acid have a no alkyl group, so it is the most acidic among this. Formic acid doesn't have any electron donating group like HCOOH. This is CH3 electron donating, C3 it's an electron donating, C4 it's an electron donating. So HCOH formic acid doesn't have any electron donating group. Hence, this will be more acidic among all these. Okay, why formic acid is more acidic than acetic acid? Because it doesn't consist electron donating group, no any other alkyl group in formic acid. Hence, it is stronger acid or stronger than acetic acid. Okay. Not only this, if we consider the minus I effect, so the group of an atom having a minus I effect increases, the acid strength will be decreased. As it decreases, the negative charge on the carboxylate ion, greater the number of such atoms in a group minus effect, greater. So understand this, minus I effect increases, the group of an atom having minus I effect increases. So the acid strength is decreases as a negative charge of carboxylate ion. If the carboxylate ion is more negative, means positive inductive, need not to understand wrongly. You need to understand properly. So minus A effect means electron withdrawing. So electron withdrawing is if it present, it drags a pair of electron towards themselves. It relates to this, not for this one. This one is positive inductive effect, and this one is negative inductive effect. On the negative charge means CHCl3. So all hydrogen are replaced with a chlorine. So trichloroacetic acid. Trichloroacetic acid is more acidic than acetic acid because CCl2 group minus negative inductive effect increases, the acid strength increases. Negative inductive effect increases, acid strength increases. The group of an atom having minus I effect increases. The acid strength as it decreases as the negative charge on carboxylate ion. So this carboxylate ion, COO minus, this decreases. If it decreases, acid strength increases. So are you getting? Carboxylate ion, the charge on carboxylate ion decreases, acid strength increases. So trichloroacetic acid is stronger acid than acetic acid. Why? Because a CH3 group is an electron donating group. Okay, and Cl group is electron withdrawing group. 3Cl group. 3Cl group. So inductive effect, negative inductive effect increases from right to left. Right? From left to right, it is decreases. So which is the more stronger acid between this trichloroacetic acid and monochloroacetic acid. Trichloroacetic acid is stronger than monochloroacetic acid. Monochloroacetic acid is stronger than acetic acid. But acetic acid, formic acid is stronger than acetic acid because it doesn't consist any alkyne group. That point also you need to remember. Okay. Not only this, if the alkyl group, formic acid and aryl group, we are discussing about only alkyl group. What about the aryl group? If any benzene group are attached to this, strength of aliphatic carboxylic acid and benzoic acid. So this is R, aliphatic R group attaches to this, and C6H5 group attaches to this. Okay, R group. The difference between R group COOH and C6H5 to COOH. So COOH and C6H5. So if it is less electron donating, is nothing but electron accepting. If it drag the pair of electron on the carboxylate ion, so charge density on oxygen decreases, hence acid strength increases. In the case of aliphatic, the positive inductive effect, electron donating group, so it donates an electron on carboxylate ion, charge on carboxylate ion is more. Charge on carboxylate ion is more, the acid strength will be less. Acid strength will be less. So hence benzoic acid is stronger than aliphatic carboxylic acid, but exception in formic acid. You need to remember formic acid is stronger than the benzoic acid or any R group. Any R group. R group is benzyl group. Okay, so C6H5 NaCH2 or R group is simply called as an aryl group. Aryl is an aryl means minimum the benzene ring should be there. It's called an aryl. So HCOH formic acid rather than C6H5COH benzoic acid rather than RCOH aliphatic carbons. Okay, so acid strength is in decreasing order. Acid strength is decreasing order. So formic acid is stronger than benzoic acid. Why? Because it's an electron donating group. Drag it compared to R group aliphatic and aromatic, we are saying this HCOH so doesn't consist any alkyl group, hence it is stronger. So compared to the aliphatic and aromatic, aliphatic are the less acidic than aromatic compound. Need to understand properly acidic strength. So acidic strength can able to explain on inductive effect. So the decreasing order of an acid, so you need to remember, because in the more group of an NO2 group, so F group, Cl group, Br group, CF3C group, Cl3C, Br3C, and I3. So that is in the decreasing order NO2. So NO2 is more electron withdrawing group now. So it's greater than FCH2, is greater than Cl, greater than Br. If more of the group attached, FCF3, so it's greater than ClF3, is greater than BrF3, is greater than I3. So need to remember the decreasing order of the acids. Need to understand properly why this negative inductive effect, why is positive inductive effect. So C6H5, so benzyl, aryl group is more electron withdrawing than this is a carbon. So what happened? Then hydrogen. Then what happened? Electron density, charge density, and oxygen decreases. Charge density and oxygen decreases, obviously acid character increases. But in this case, electron is donating to the carboxylate ion, or in carboxylate ion, oxygen will be having greater charge. Greater charge is less acidic. Less acidic. Okay, I hope you are getting this point. That is important towards the acidity, acid strength. Okay, especially the acid strength with respect to the inductive effect is very important. You need to remember. Okay, next. After that, the acid strength is the relative strength of the bases. So base, especially amines. Okay, especially in the case of amines. In amines, NH2 group, NH group or NH2 or NH3 group. Okay, in this case, so it is how it can be defined. So bases are so capable of accepting of the proton. What are the bases? Bases are capable of accepting the protons. If they are capable of accepting of an electron, what happens in this? Capable of accepting the what will be the basic nature? Cl NH2, NH3, CH3, CH2, C2H5. So what we are noticing here, so electronegative group, here that an electron donating group, electron donating group, electron donating group. So what it will be indicates, so the compounds will be more basic when the positive inductive effect, and will be less basic than negative inductive effect, minus I effect. When electron donating group donates an electron between carbon and alkyl group, or group donates electron on the carbon, or any other group like NH group or NH. Look, we are discussing about amines. No, we can take a nitrogen and oxygen, nitrogen and hydrogen. So that is chloroamine or ammonia NH3 or methylamine CH3NH2. C2H5NH2 is called ethylamine. C2H5 twice diethylamine. In that, what we are noticing, carbon, so more of towards from right to left, more of the substituent group, positive inductive effect. These are electron donating, not an electron accepting. Electron accepting, the chloride, Cl is an electron accepting. If the chlorine is electron accepting, will be having the less basic. Okay, less basic. So we know that the aniline C6H5NH2, C6H5NH2 in benzene ring also. So what happens? This NH2 aniline is less basic than diphenylamine, still more weaker. So why these things will be happen? Because of the inductive effect. We can able to explain because of inductive effect. As compared to ammonia, so NH3, methylamine is more basic. So methylamine CH3 NH2 is more basic. Why? Because electron donating group. Electron donating group, positive inductive effect. Positive inductive effect. Okay, but aniline is less basic, and diphenylamine is still more weaker base. Diphenylamine is still more weaker base of because of minus I effect of phenyl group. So C2H5, so diphenylamine C2H5 group, if it drags a pair of electron group, then obviously it will be decreases. Phenyl group is C6H5. So understand, diphenyl is differ, diethylamine is differ. This is diphenyl C2H5. Okay, this is ethyl. This is more basic. This is less basic. Understand properly. Okay, the difference between the basic character. So how the basic character varies in between of the alkyl as well as in aryl amines. Okay. In the case of you can notice now here and this one CH3 twice C2H5 twice NH diethylamine, Cl NH2 chloroamine, CH3 NH2. Okay, that is methylamine, C6H5 NH2. That is aniline, C6H5 NH2 aniline, NH3 ammonia, diphenylamine, C6H5 twice NH. This is what we call as aniline. aniline, C6H5, NH2. So compared to this ammonia onwards, chlorine, more electronegative withdrawing group, more electron withdrawing group, more electron withdrawing group. So from left to right, more electron withdrawing group. So that is greater minus negative inductive effect. So drag the pair of electron away on this from the carbon. Then what happens? Then basicity decreases. Acidity increases, basicity decreases. In the case of positive inductive effect, acidity decreases, basicity increases, opposite with each other. Okay. Understand properly to write organic reactions, you have to know it clearly how the acid and basic strength, how the acidity and basicity, which with respect to the inductive effect, you need to know properly, right? So here, with respect to, we'll take from nitrogen and hydrogen ammonia with compound greater than or less than. So this towards an methyl or ethyl or diethyl and other compounds, what we are noticing, no, they the more electron donating, okay, more electron donating group, what happened? Then basicity increases. So more electron withdrawing group from NH3 to C6H5NH2, from C6H5NH2 to C6H5 twice NH2, C6H5NH2 aniline to diphenylamine. So in this more electron withdrawing, basicity obviously decreases. Basicity decreases. So we call it as weaker base. So you need to know the basic strength. More electron withdrawing group, plus I effect, then basicity is more, and the negative inductive effect minus I effect, the basicity decreases. So this is with respect to inductive effect of the basicity, especially amines, basic strength of amines. You need to know it. Are you getting? Okay. Next. After this, so we have to know how the acids in alcohol, acidic strength in alcohols. Alcohols, we know that will be having functional groups of ROH. Okay, ROH is functional group of an alcohol. Okay, so alcohol, ROH. So in this, acidity of alcohol depends on the stability of alkoxide ion. Alkoxide ion, how it will be dissociates. ROH dissociates to form RO minus and H plus. This RO minus is called alkoxide ion. Okay, this alkoxide ion stability depends on this stability, acidity of alcohol. This depends on alkoxide ion. Okay, so how this will be dissociates in this strength of an alcohol proportional to stability of alkoxide ion, decreasing order of the acid strength. Alcohol is also strength of alcohol due to plus I effect. So here you need to understand these words. Acid strength of alcohol proportional to stability of alkoxide ion. This depends on alkoxide ion. Okay, then the decreasing order of acid strength in alcohol is due to plus I effect. Negative inductive effect. So decrease in the order of the negative inductive effect. You can notice here in the case of the methyl alcohol to tertiary butyl alcohol. So in methyl alcohol, that's CH3OH, OH group, alkoxide ion with the substituent group, OH group and the two substituent group, OH with the isopropyl alcohol, mode substituent group, and OH with the mode of substituent group. So what happened? The acid strength of alcohol is proportional to alkoxide ion. The decreasing order of acid strength in alcohol is due to positive inductive effect. So plus I effect, more of electron withdrawing, electron donating group. Here is one electron donating group. Here is the two C2H5 electron donating group. Tendency of electron donation is more. Again, the tendency of electron donation. What happens in this carbon? This carbon will be decreases, but this carbon will be increases. No? So what happens to this? How is the order? Methyl alcohol CH3OH is greater than the ethyl alcohol because there will be more of the substituent group. Acid strength of alcohol directly proportional to alkoxide ion, or O minus is called alkoxide ion, and H plus because tendency of donation of H plus, no, there is hydrogen ion. This acidity in alcohols is also we can able to explain with the help of inductive effect, that is positive inductive effect. Plus I effect, more electron donating group. Then what happened? There will be decrease in the order of acid strength in alcohols is due to plus I effect. Acid strength will be decreases due to more electron donating groups. More electron donating groups. So methyl alcohol is greater than ethyl alcohol, greater than tertiary butyl alcohol. So this is we need to remember acid strength. Okay, positive due to positive inductive effect or plus I effect. Next, at last, in the application of inductive effect is dipole moment. As inductive effect increases, the dipole moment decreases. So inductive effect increases, how it is relates to dipole moment. Already you studied dipole moment. Okay, in CH3I methyl iodide. So what happened? Methyl iodide, bromide, and chloride. So what happened? So 1.64, 1.79, 1.83 dipole moment. Okay, inductive effect increases from iodine to chlorine. So less electron withdrawing among the halides. Iodide is less electronegative. So less electronegative, electron withdrawing capacity is lesser. Come to bromine, little increases. More electron more shifted towards bromide. And carbon to chloride, it will be completely more partial positive charge is more, means shifting of electron towards this is more, and shifting of electron towards this is lesser. Okay, so I'll write the shifting of electron more towards chloride, lesser towards bromide, towards iodide is lesser. So there is a reason. So we'll be having the positive charge on carbon is this in the case of carbon to first carbon means methyl iodide and methyl chloride. So on the carbon, the greater the positive charge on the methyl chloride than methyl iodide. Hence, the dipole moment is also increases. So inductive effect increases. With increase in inductive effect, the dipole moment is also increases. So these are the factors. These are the application. Especially, we need to remember how the inductive effects, inductive effect affects on stability of carbocation, stability of, so what we discussed until now, stability of carbocation, stability of C plus carbocation, as well as stability of carbon anion, stability of carbon anion, as well as stability of carbocation, carbon anion, and acidic strength in, so the bases, acidic strength in acids and bases, and especially in amines. We discussed about amines. In acid strength, especially in carboxylic acid, COOH, carboxylic acid strength, and alcohol, the acid strength in alcohol, the bases in ammonia are amines compounds with respect to ammonia, and the dipole moments. These are the application. If you understand properly how this inductive effect affects on the acidity, basicity, and the dipole moment, stability of carbocation, it will be easier for you to understand the organic chemistry. Okay, I hope you are getting this. Okay, this is the first effect, displacement of the electron. So electron displacement effect. So we'll see one more, and then we'll wind up the session. We'll continue in the next session. Okay, so the next effect is electromeric effect. So first effect, we said that the first one is an inductive effect. An inductive effect is a permanent effect, right? There will be transfer sigma electron. There will be huge difference between inductive effect as well as an electromeric effect. Inductive effect to electromeric effect. So in the case of electromeric effect is a temporary effect. So how it can be defined? It is defined as the complete transfer of shared pair of pi electrons, complete transfer of shared pair of pi electrons to one of the atom joined by multiple bonds on the demand of attacking reagent. So we need to understand properly, it is a temporary effect. It is a temporary effect. So complete transfer of shared pair of pi electron. Pi electron is nothing but what the firstmost bond is formed, sigma, and the next bond is pi bond. So pi electron transfer, so complete transfer of pi electrons to one of an atom joined by multiple bonds, one sigma and another pi. And the demand of attacking reagent, whether the attacking reagent is an electrophile or a nucleophile. Electrophile or nucleophile, need to understand. So what is this? It is a phenomena. It is a phenomena of movement of electron from one atom to another in a multiple bond. It is a phenomena of movement of electron from one atom to another in a multiple bond at a demand of attacking reagent. Okay, I'll write this how the shifting of an electron, how it will be divided. So we'll see later. So first is you need to know the definition. It is defined as complete transfer of shared pair of sigma electrons to one of the atom joined to multiple bond and the demand of attacking reagent. It is a temporary effect, you need to remember. Okay, so example, I'll take the compound like alkene, carbon-carbon, double bonded compound. Here CH2 and CH2 double bond CH. For this, if hydrogen will be attacking reagent, proton is attacking reagent. Okay, this is attacking reagent. I'm saying this is an H plus. I donated from any other group. Okay, so what happens to this? If the attacking reagent way it needs to attack, So based on the attacking reagent, even the electrons of the pi are transferred to atom which is attacking reagent. If an electron, if hydrogen attaches to this, if pi of electron is shifting sigma electron will be, and this is the pi electron. If the pi electron shifts on this carbon, electron density will be more. If the electron density is more, attacking reagent will be attacks on this carbon. Then attacks on this carbon, what will happen? So carbon, here 2 of hydrogen with the less of one bond, no, positive charge, and will be forming with carbon as usual 2 hydrogen bond, and along with that, this is the attacked hydrogen. Okay, here is hydrogen. So I'll erase this hydrogen, don't get confusion with this 2 hydrogen. Okay, this. And this is attack the hydrogen. This hydrogen attacks on this. Okay, where which carbon? If the pi of electron attacks the shared pair of electron, means pi electron attached to the carbon where the attacking reagent is attacked. That is called plus E effect, positive electromeric effect. Okay, so this electromeric effect divided into 2 types: positive electromeric effect and negative electromeric effect. So understand properly. Okay, it is a temporary effect which involves in complete transfer of pi electron. So instead of reverse, opposite, if the attacking reagent is nucleophile, so carbon-carbon double bond. So 2 types. If the pi electron attacks to another carbon, pi electron attaches to another group, instead of C, any one group should be more. No, I'll take a carbonyl group. I'll take the carbonyl, C double bond O group. C double bond O group, ketone group. No, so C double bond O group. If the C double bond O group, then shade pair, oxygen is more electronegative than carbon. No, so shade pair of electrons shift on oxygen. If it shifts on oxygen, then attacking reagent is a nucleophile. Attacking reagent Cn minus, nucleophile. So shared pair of electron shifts on oxygen. Due to that, carbon on this carbon will be forming, this carbon will be having negative charge. because pair of electrons shifted on oxygen. So what happens to carbon? Carbon forms positive charge. Now, due to this positive charge, attacking group attacks on this carbon cyanide group attaches to this. If it attaches to this, then it is called negative electromeric effect, minus E effect. Need to understand properly positive electromeric effect and negative electromeric effect. What is negative electromeric effect? When an electron of the pi bond, double bond, transfer to the atom with one which has reagent gets finally attached. So transfer of electron is transferred. Pi bonded it transfer of an atom other than, not to this atom, other than the attached group. Reagent transfer of electron attached to which carbon the reagent attached or reagent attack, that is called Plessy effect. Other than the attacking group, where the group is attacking opposite to that, other than that group, the transfer of electron will take place, that is called negative electromeric effect. Okay, positive electromeric effect and negative electromeric effect. What is positive electromeric effect? What is positive electromeric effect? Positive electromeric effect is nothing but this attacking reagent where it will be attached to the same group, the sigma electron, to the same group, to same group, pi electron will transfer. What is negative electromeric effect? Where the attacking group is attached, other than that, here CN group attaches to a carbon, other than that, the group pi electron will be shifting to other atom. That is called negative electromeric effect. Positive electromeric effect and negative electromeric effect. Are you getting? So simple, easy to understand. Where the group is attached, the same, on the same group, the pi bond is shifting. So then it is called positive electromeric effect. Where the group is attached opposite to that, the pi bond is shifted, then it is called negative electromeric effect. I hope you are getting positive electromeric effect and negative electromeric effect. So we need to see important features of electromeric effect. It is a temporary effect. It takes place only in the attacking reagent. In presence of attacking reagent, only it will be takes place. Hence, it is a temporary. And this effect involved in complete transfer of pi electron, not a sigma, pi electron, delocalization of pi electron. So in this observation, organic compound containing multiple bond should be consist double or triple bond. Okay, and this will be displaced electron, leave their orbit and the new position. Because in sigma, we said that valence electron will be there in the sigma electron will be there in the valence shell itself. That is permanent effect. Here, temporary effect, which leaves that orbit and forms, which will goes to the new position, take a new position. So, in this complete charge separation and ions are formed. Here, the complete charge separation and ions will be forming. This divided as positive inductive effect and negative inductive effect. So these are the important features of electromeric effect. So we'll see the important features of electromeric effect. It is a temporary effect, takes place in presence of attacking reagent. So it affects involved and compared to, so a complete transfer of pi electron, right? So complete transfer of pi electron, it will be takes place here. Then it is observed in organic compound containing multiple bond, double or triple bond. This effect displaces an electron, leave their orbit and take new position, and their complete charge separation, ions are formed, compound. And these are two types: positive electromeric effect and negative electromeric effect. Okay, you know that what is positive electromeric and negative electromeric. Just I'll say once again. What is it? In this effect, pi electron of multiple bond transfer to the atom, which reagents get attached. Okay, where the reagent get attached to the same. Look here, no, this carbon attaches to same. In presence of attacking reagent only, this will be happen. So carbon attaches to this because pi electron shift here. The pi electron shift here, another carbon will be getting partial positive charge, complete positive charge, and this hydrogen attack on the negative means electron rich area. This is called positive electromeric effect plus E effect. Okay, so opposite to this, the group where the attacking group is attacked, opposite to that means other than the attached group is the shifting of pi electron will takes place, then it is called electromeric effect. Are you getting? So pi electron, you're shifting to on the oxygen, so we'll be having partial positive charge. So what happened? This carbon will be having CH2 of hydrogen. So this cyanide group attached to this carbon because oxygen will be having negative charge. Okay, CHO is called formaldehyde, but the structure is, HCHO is called formaldehyde. Okay, this is an example of formaldehyde. This is an anion will be having charge, negative charge. Okay, this is positive electromeric effect and negative electromeric effect. Are you getting? So we are discussing about displacement of electron. That two important displacement effects we study: inductive effect and electromeric effect. Okay, so we'll list out the difference between inductive effect and electromeric effect. So inductive effect and electromeric effect. Inductive effect and electromeric effect. So we'll see the notice. We'll identify. We'll see the difference between inductive effect and electromeric effect. No, so this is in this side inductive effect and this side electromeric effect. Inductive effect and electromeric effect. Right. So first one, an inductive effect. What is this? So list out the list the inductive effect. Yes, first one, an inductive effect. It is a permanent effect, right? It is a permanent effect. What about the electromeric effect? It is a temporary effect. It is temporary effect. In this inductive effect, so slight drifting of shared pair of electron, not complete transfer. Sigma electron towards more electronegative or sigma electron drift, we call as drifting. Drifting of sigma electron. Drifting of sigma electron means dragging of pair of electron, partial positive charge, partial negative charge will form. Okay, in the electromeric effect, this is complete transfer of pi electron. Complete transfer of pi electron. So here what it forms, one of the bond, any one of the bond, complete transfer of electron from any one of the bond in electromeric effect. And it doesn't need any outside reagent, doesn't require any reagent or attacking reagent. But electromeric effect requires in presence of attacking reagent only, in presence of any outside reagent only, the electromeric effect will take place. It involved in the partial separation of charge without forming ion. This is partial separation of charge. Partial separation of charge. So we are using delta plus or delta minus, right? Partial positive charge or partial negative charge. So there is no formation of ion, But in the case of electromeric effect, it is complete transfer of electron from the reagent to a substrate, and it's vice versa. This results in the formation of ions, and complete ion will be forming. Okay, these are the difference between inductive effect and electromeric effect. Are you getting? So the rest of the effect, the rest two effect, resonance effect and hyperconjugation. Resonance effect and hyperconjugation will discuss in the next session. Thank you.